I bet you didn't know some animals see impossible colors, or that others use sound to see in total darkness. These aren't just fascinating quirks of nature, they are genuine superpowers, sensory abilities so advanced they challenge our very definition of reality. So why aren't more people talking about them? The world we perceive, the one you're looking at right now, is built by our senses. But what if I told you that what we see, hear, and smell is just a tiny fraction of what's really out there? Humans see a slice of reality, just a sliver. We live inside a sensory bubble, tuned to a very specific, very narrow band of information. But in the animal kingdom, that bubble bursts. Every sense is dialed up to 11, creating millions of different realities, each one unique to the creature experiencing it. Today, we're going on a journey beyond the limits of human perception. If you're ready to have your mind blown and see the world in a completely new way, do me a favor and hit that like button, subscribe to the channel, and ring the bell so you don't miss our next exploration into the unknown. Let's start with sight. You're looking at the mantis shrimp, a creature that experiences a world of color we can't even begin to comprehend. Humans have 3 types of color-receptive cones in our eyes, allowing us to see the familiar rainbow of red, green, and blue light combinations. It feels complete to us. But the mantis shrimp? It has between 12 and 16. They see colors beyond our wildest dreams. They can perceive ultraviolet light, a spectrum invisible to us, which might make flowers and mates glow in ways we can only imagine. They can also see polarized light, detecting the orientation of light waves. This could allow them to see otherwise transparent prey shimmering against the water, or send secret coded messages to each other that are invisible to predators. Their world isn't just more colorful than ours, it contains layers of visual information that are fundamentally inaccessible to us. But what about seeing when there's almost no light at all? For that, we turn to the masters of the night, like the owl. Owls can spot a mouse in near darkness, from hundreds of feet away. How? Their eyes are less like spheres and more like giant, light-gathering tubes, packed with an incredible density of rod cells, the photoreceptors responsible for vision in low light. More importantly, they possess a secret weapon, the tapetum lucidum. This is a reflective layer behind the retina that acts like a mirror. Any light that passes through the retina without being absorbed is bounced back for a second chance. It's the reason a cat's or dog's eyes seem to glow in the dark when hit by light. For an owl, it means that not a single precious photon of moonlight goes to waste, creating a world of clarity in what we would call pitch black. And then there's the chameleon, whose eyes defy the basic rules of vision as we know it. Chameleons can swivel their eyes in 2 different directions at once. This gives them a panoramic, nearly 360-degree view of the world. One eye can be scanning the leaves above for a tasty insect, while the other is watching the ground below for snakes. It's the ultimate multitasking. But here's the truly incredible part. When it spots prey, it can instantly snap both eyes forward, switching from 2 separate monocular images to a single high-precision binocular image. This gives it incredible depth perception, allowing it to judge distance with pinpoint accuracy before launching its lightning-fast tongue. It's like having 2 independent cameras that can merge into a single powerful telephoto lens at will. Now let's leave the world of light behind and enter a realm where sound becomes sight. Bats are famous for navigating in absolute darkness. They see with sound, mapping the world with echoes. This process, called echolocation, is a biological marvel. The bat emits a stream of high-frequency clicks, far too high for humans to hear. These sound waves travel out, hit objects in the environment, a cave wall, a tree branch, a tiny moth, and bounce back as echoes. The bat's exquisitely sensitive ears and specialized brain analyze the time it takes for these echoes to return, their intensity, and the subtle shifts in frequency. From this information, it constructs a rich, detailed, 3-dimensional map of its surroundings in real time. It can determine an object's size, shape, texture, and even its speed and direction of travel, all from sound alone. This incredible ability isn't limited to the air. Dolphins use echolocation to see underwater with precise clicks and echoes. Sound travels over 4 times faster in water than in air, making it a perfect medium for sensory exploration. A dolphin forces air through its nasal passages to create clicks, then focuses them into a beam using a fatty organ in its forehead called the melon. The returning echoes are received through its lower jaw, which transmits the vibrations to its inner ear. This system is so sophisticated that a dolphin can not only locate a fish in murky water, but can also determine its size and shape. It can even tell the difference between a golf ball and a ping pong ball based on their density. Some research suggests their echolocation is so powerful. It functions like a biological ultrasound, allowing them to see inside other creatures, detecting the skeleton or even a developing calf inside its mother. But hearing isn't just for ears. For the largest land animal on Earth, it's also for their feet. Elephants listen through their feet, picking up distant rumbles. They communicate using infrasound, deep, low-frequency calls that are below the range of human hearing. These powerful sound waves can travel for miles, not just through the air, but through the ground itself. Elephants have large, fatty pads on the soles of their feet that are packed with vibration-sensitive nerve endings. By pressing their feet and trunks to the ground, they can detect these seismic signals from other herds, warning of predators, announcing a source of water, or coordinating movements over vast distances. They are literally having conversations through the solid earth. Now we venture into senses that seem truly alien. Imagine being able to feel the electricity of life itself. Sharks can. They sense the faint electric fields generated by all living things. Every time a fish flexes a muscle or its heart beats, it creates a tiny bioelectric field. Sharks, rays, and skates can detect these fields using a network of jelly-filled pores on their snouts called the ampullae of Lorenzini. This sixth sense, known as electroreception, allows them to find prey that is completely hidden from sight, buried under the sand or camouflaged against a reef. It's an invisible world of electrical energy, and the shark is its undisputed master, navigating and hunting in a dimension we can't even begin to perceive. And what about smell? We think we know what it's like to smell a flower or a meal, but for a dog, that experience is exponentially more profound. A dog's sense of smell is estimated to be anywhere from 10,000 to 100,000 times more acute than ours. The part of their brain devoted to analyzing smells is, proportionally, 40 times larger than ours. To put that in perspective, what we might smell as a cup of coffee, a dog could likely smell every single component. The coffee beans, the water, the filter, the trace minerals. This is why dogs can sniff out diseases in humans and animals we can't detect. They can smell the incredibly subtle volatile organic compounds released by cancer cells, or the chemical shifts associated with a diabetic's blood sugar. They are living, breathing medical diagnostic tools, reading a world of chemical information that is completely invisible to us. So, take a moment. Try to imagine combining all these senses. Imagine a world where your sight is enhanced beyond ours, seeing polarized light and ultraviolet patterns on everything around you. Where sound isn't just something you hear, but something you see. Hearing echoes as clear spatial images around you, painting a picture in total darkness. Where smell is a tapestry of information, allowing you to track faint chemical trails from miles away, reading the history of who has been there and what they were feeling, like a living nose. And where you can feel electricity, sensing the tiny invisible fields emitted by hidden animals nearby. A constant awareness of the life force pulsing all around you. This isn't science fiction. This is the everyday life for countless animals around the planet. Each creature lives in its own sensory universe, its own Umwelt, tailored perfectly for its survival. So next time you watch your pet, remember that they are experiencing a version of your home that you can never fully know. They are smelling its history, hearing sounds from blocks away, seeing things in the dim light that are invisible to you. And when you spot wildlife in its natural habitat, recognize that you are only a visitor in their world, catching a fleeting glimpse of a reality far richer and more complex than your own. There's a whole world we'll never fully sense. It's a humbling thought, but also an incredibly exciting one. It reminds us that the world is so much bigger, so much more mysterious than it appears. It's a call to stay curious. So, I'll ask you, if you could borrow one of these abilities for a day, what animal super sense do you wish you had?